All right, thank you for joining us today. And in this video, we are going to talk about Leibniz Theorem, still in the process of practicing. Let's jump right in. So we have this nice question here. That this one too, we want to find, you know, y prime prime for this function here using the Leibniz theorem, right? So we have y, which is equal to sine inverse of x squared. Now, how are you going to do this? You see here, if I start by differentiating the function, let's say y prime, this one I need to use the power rule or the change rule, right? Which 2 will drop down, I subtract 1, I maintain this and differentiate sine inverse, which I'm going to still have the sine inverse inside the question. So because of that, what I need to do is I need to simplify the function. I need to make sure that sine inverse is standing alone without this power here. Then what can I do to take this power out? Then I need to take root of this so that this one take this and then take root of that. So what I'm going to do is I pick root. Root is the same as 1 over 2, which is the same as sine inverse of x squared times 1 over 2. It's the same as taking the root. Then this is going to give us y1 over 2, which is equal to sine inverse of x. This helps us to get sine inverse to stand alone, right? So that we can differentiate, and then our functions are going to be in terms of only y and what x, right? So now let's differentiate. When I differentiate this, I'm going to use the power rule. So I'm going to have 1 divided by 2 y, then I will subtract 1 from this. So this is going to give us negative 1 over 2 times y prime. So when I differentiate y, since I'm differentiating with respect to respect to x, when I finish, I need to differentiate it by what? I need to multiply it by y prime. Then from the previous video that we did, we learned how to differentiate sine inverse, and we said it is 1 divided by root of 1 minus what? X squared. So this is what we are going to have, or this is what you are going to what? Get. So as I said, always make your life very simple. Make things simple for you to get along with, right? So this one, I can write this one as y prime divided by 2y to the power 1 over 2, which is equal to 1 divided by root of 1 minus x squared. So I'll multiply this one by this and this one by that. So I'm going to have y prime root of 1 minus x squared, which is equal to 2y 1 over 2. So since we have the root here, what I need to do is I need to make sure I square here, to make sure that I take care of the root before I start with the second derivative. Oops, I like writing prime a lot. It's supposed to be y1. So when I square this, then I need to square this one too as well, right? So as we said, if I have a, b all squared, this is the same as a squared times b squared, if they are product, right? So this is going to give us y1 squared times, then I will square this one, but when I square this one, this will cancel that. So I'm going to have 1 minus x squared, which is equal to, I will square this one, that one will give us 4. Then when I square this will cancel that. So we are going to have just y. So you see the way now it has become, we can now take the second what? Derivative. And taking the second derivative, this becomes what? Product rule. So first I maintain y1 squared. When I differentiate the one in the bracket, I'm going to have negative 2x plus. Now I maintain 1 minus x squared here and differentiate this. So I think we did this sum in the previous video. This is going to give us 2y1 y2, right? So power rule, 2 goes down, which is here. I subtract 1. So this one, when you subtract 1, it will be left with just y1. Then I need to differentiate y1 again, which will give me y2. And this is going to be equal to 4. When I differentiate y, I'll get y1. So that's what I'm going to have. Then I have y1 here, I have y1 here, I have y1 here. So this one will cancel this one will cancel this, and one of the y1 will cancel one of the y1 also here. So what are we going to get? We are going to have, when I divide this one by that, I'm going to have negative 2x y1 plus 1 minus x squared. Let me add the 2 in front, y2, which is equal to 4. So by simplifying this, I'm going to have 2, or I can even divide 2 by 2, divide 2 by 2, divide 2 by 2, right? So when I do that, I'm going to have negative x y1 plus 1 minus x squared y2, which is equal to 2. So finally, we are going to have something like this. If I want to bring this term first, I'm going to have 1 minus x squared y2 minus y1 minus 2 is equal to 0. So this is what we are going to have with some of the terms. Now, the same examples, we've used this approach. I'll do another video where we just need to differentiate the function straight away from this, and we will see what we are going to get at the end of the day. So sometimes it all depends on where we are getting to. If it's session B, sometimes it's better for you to use this. But if it's session A, always check the results or check your answer before you start solving it. Because maybe you are using this way, but your results are not going to give you the solution that you are going to get here. But maybe the one that you need to do the differentiating straight. But since the question is asking to use the Leibniz Theorem, then it's better for you to go through this process. So see you in the next video.